Now on Nova. Take a thrill ride into a world stranger than science fiction, where you play the game by breaking some rules, where a new view of the universe pushes you beyond the limits of your wildest imagination. This is the world of string theory, a way of describing every force and all matter, from an atom to Earth to the end of the galaxies, from the birth of time to its final tick, in a single theory, a theory of everything. Our guide to this brave new world is Brian Greene, the best-selling author and physicist.
And no matter how many times I come here, I never seem to get used to it.
Can he help us solve the greatest puzzle of modern physics? That our understanding of the universe is based on two sets of laws that don't agree. Resolving that contradiction eluded even Einstein, who made it his final quest. After decades, we may finally be on the verge of a breakthrough. The solution is strings. Tiny bits of energy vibrating like the strings on a cello. A cosmic symphony at the heart of all reality. But it comes at a price. Parallel universes and 11 dimensions, most of which you've never seen.
We really may live in a universe with more dimensions than meet the eye.
People who've said that there are extra dimensions of space have been labeled crackpots or people who are bananas.
A mirage of science and mathematics? Or the ultimate theory of everything?
If string theory fails to provide a testable prediction, then nobody should believe it.
Is that a theory of physics or a philosophy?
One thing that is certain is that string theory is already showing us that the universe may be a lot stranger than any of us ever imagined.
Coming up tonight, it all started with an apple.
The triumph of Newton's equations come from the quest to understand the planets and the stars.
And we've come a long way since.
Einstein gave the world a new picture for what the force of gravity actually is.
Where he left off, string theorists now dare to go. But how close are they to fulfilling Einstein's dream? Watch The Elegant Universe right now.
Major funding for NOVA is provided by the Park Foundation.
Science. It's given us the framework to help make wireless communications clear. Sprint is proud to support NOVA.
We see an inventor. At Microsoft, your potential inspires us to create software that helps you reach it. Your potential, our passion.
Funding for The Elegant Universe is provided by the Alfred P. Sloan Foundation to enhance public understanding of science and technology. And by the National Science Foundation, America's investment in the future. Additional funding is provided by and by the George D. Smith Fund and the U.S. Department of Energy, fostering science and security. Major funding for NOVA is also provided by the Corporation for Public Broadcasting and viewers like you. Thank you.
50 years ago, this house was the scene of one of the greatest mysteries of modern science. A mystery so profound that today, thousands of scientists on the cutting edge of physics are still trying to solve it. Albert Einstein spent his last 2 decades in this modest home in Princeton, New Jersey. And in his second-floor study, Einstein relentlessly sought a single theory so powerful it would describe all the workings of the universe. Even as he neared the end of his life, Einstein kept a notepad close at hand, furiously trying to come up with the equations for what would come to be known as the theory of everything. Convinced he was on the verge of the most important discovery in the history of science, Einstein ran out of time, his dream unfulfilled. Now, almost a half-century later, Einstein's goal of unification, combining all the laws of the universe in one all-encompassing theory, has become the holy grail of modern physics. And we think we may at last achieve Einstein's dream with a new and radical set of ideas called string theory. But if this revolutionary theory is right, we are in for quite a shock. String theory says we may be living in a universe where reality meets science fiction. A universe of 11 dimensions, with parallel universes right next door. An elegant universe composed entirely of the music of strings. But for all its ambition, the basic idea of string theory is surprisingly simple. It says that everything in the universe, from the tiniest particle to the most distant star, is made from one kind of ingredient: unimaginably small, vibrating strands of energy called strings. Just as the strings of a cello can give rise to a rich variety of musical notes, the tiny strings in string theory vibrate in a multitude of different ways, making up all the constituents of nature. In other words, the universe is like a grand cosmic symphony, resonating with all the various notes these tiny, vibrating strands of energy can play. String theory is still in its infancy, but it's already revealing a radically new picture of the universe, one that is both strange and beautiful. But what makes us think we can understand all the complexity of the universe, let alone reduce it to a single theory of everything? We have r mu nu minus a half g mu nu r, you remember how this goes, equals 8 pi g t mu nu. It comes from varying the Einstein-Hilbert action, we get the field equations, and this term, remember what this is called? No, that's the scalar curvature. This is the Ricci tensor. Have you been studying this at all?